Does India face earthquakes? Many people believe earthquakes happen only in other countries, but India has also experienced several major earthquakes. One of the most devastating occurred in Gujarat in 2001. Thousands of people lost their lives, buildings collapsed, roads cracked, entire communities were affected. India is especially vulnerable because the Indian plate is still moving northward and colliding with the Eurasian plate. This ongoing collision continues to build pressure beneath the Earth's surface. As a result, the Himalayan region and several other parts of India remain earthquake-prone. This is why engineers design buildings differently in high-risk areas. Scientists continuously monitor seismic activity. Governments prepare disaster management plans. Understanding plate tectonics is not just about passing an examination, it helps us identify regions that are more vulnerable and prepare for natural disasters. One powerful reminder of the Earth's activity can be seen through volcanoes. Although they may look terrifying, they also reveal what is happening deep inside our planet. When we hear the word volcano, many of us imagine a mountain exploding with fire. In reality, a volcano is an opening in the Earth's crust, through which molten rock, gases, and ash escape from deep inside the Earth. This molten rock is called magma while it remains underground. Once it reaches the surface, it is called lava. Volcanic eruptions can create entirely new landforms, but they can also destroy forests, roads, and settlements. The grey ash released during eruptions may cover entire towns. Although volcanic eruptions can be destructive, they also make the soil more fertile in many regions over long periods of time. India has its own fascinating volcanic feature. The Baratang Mud volcano, located in the Andaman and Nicobar Islands. Unlike ordinary volcanoes, it does not erupt with hot lava. Instead, it releases mud, water, and gases from beneath the Earth's surface. It is one of the rare natural wonders found in India and reminds us that our planet continues to remain active beneath our feet. Take one final look at a mountain or a volcano, or even a photograph of the Himalayas. They may appear silent, still, unchanging. But now you know the truth. Deep below them, the Earth is always moving. Gigantic plates continue their slow journey. Heat continues flowing through the mantle. Pressure continues building beneath the crust. Our planet is never truly at rest, but building mountains is only one part of Earth's story. Once these landforms are created, another set of powerful forces begins shaping them all over again. Imagine building a beautiful sandcastle on the beach. It looks strong, perfect, but after a few hours, the waves slowly begin to wash it away. The wind blows away tiny grains of sand. Rain softens its walls. Little by little, the sandcastle changes shape. Nature is doing exactly the same thing to mountains. Not in a few hours, but over thousands and even millions of years. Even the tallest mountains on Earth are constantly being broken down and reshaped. This continuous process is called gradation. Gradation means the wearing down of high areas and the filling up of low areas by natural agents. Nature is like a giant sculptor, always carving, breaking, moving, and rebuilding the Earth's surface. Weathering, breaking rocks apart. Imagine leaving a brick outside your house for many years. Hot summers, heavy rains, cold winters. Slowly, small cracks begin to appear. The brick becomes weaker. Eventually, tiny pieces start breaking off. The same thing happens to rocks in nature. This process is called weathering. Weathering is the breaking down of rocks into smaller pieces without moving them from their original place. The rocks simply break apart. They do not travel anywhere yet. Weathering can happen because of changes in temperature, the action of water, the growth of plant roots, or chemical reactions. Although weathering is a very slow process, it prepares rocks for the next stage. Once rocks have been broken down, nature doesn't stop there. Now, it begins moving them. Imagine sweeping away the broken pieces of that brick. The pieces are no longer in the same place. They have been carried away. This is exactly what happens in nature. After rocks are broken down by weathering, they are carried away by moving water, wind, glaciers, or sea waves. This process is called erosion. Erosion is the removal and transportation of weathered materials from one place to another. Nature is no longer just breaking rocks, it is transporting them, sometimes only a few meters, sometimes hundreds of kilometers. Deposition, the journey comes to an end. Imagine carrying a heavy school bag. You keep walking. Eventually, you become tired, so you place the bag on the ground. Nature behaves in a similar way. Rivers, wind, glaciers, and sea waves cannot carry sediments forever. At some point, they lose energy. When that happens, they drop the materials they were carrying. This process is called deposition. Together, weathering, erosion, and deposition continuously reshape the Earth's surface. These three processes have been working for millions of years, and they continue even today. Nature's four great sculptors. Four major natural agents shape the Earth's surface: running water, sea waves, glaciers, wind. Each one works differently, but all of them slowly change the landscape around us. Let's meet each of these natural sculptors one by one. Imagine a tiny stream flowing down a mountain. At first it looks harmless, but year after year, century after century, it keeps flowing. Slowly, it cuts into solid rock. The small stream grows into a river. The river deepens its channel. It carries rocks, sand, and soil. Over time, it creates valleys that are hundreds of meters deep. Running water is one of the most powerful agents of erosion on Earth. Although water appears soft, its continuous movement can reshape entire landscapes. Waterfalls where rivers leap. As rivers flow downhill, they do not always travel over flat land. Sometimes they reach a steep cliff. Instead of flowing gently, the water suddenly falls. This creates a waterfall. One famous example is Jog Falls in Karnataka. Every waterfall slowly erodes the rocks beneath it. As this continues, the waterfall gradually moves backward over thousands of years. Even waterfalls, which appear permanent, are constantly changing. Meanders, rivers that begin to dance. When rivers reach flat plains, their speed decreases. Instead of flowing straight, they begin bending from side to side. These winding curves are called meanders. Imagine drawing a snake across a sheet of paper. That twisting pattern is similar to the path followed by many rivers. Over long periods, some bends become so large that the river eventually cuts across them. The old curved section becomes separated from the main river. This creates an oxbow lake. A river that once flowed through the bend now leaves it behind as a peaceful lake. Every river carries sediments, sand, clay, small stones. As the river reaches the sea, its speed slows down. It can no longer carry all these materials, so it deposits them near its mouth. Over thousands of years, these deposits build up. Gradually, new land is formed. This landform is called a delta. One of the largest deltas in the world is the Ganga-Brahmaputra Delta, shared by India and Bangladesh. It is rich in fertile soil and supports millions of people. Now let's leave the rivers behind and travel to the coast. Stand on a beach, watch the waves. One wave reaches the shore, then another. It looks gentle. But remember, this has been happening every single day for millions of years. Slowly, the waves wear away coastal rocks. This process creates many beautiful coastal landforms, steep sea cliffs, openings called sea caves, natural bridges known as sea arches, and isolated rock pillars called sea stacks. Every one of these landforms tells the story of waves patiently shaping the coastline over enormous periods of time. Imagine a river that doesn't flow with water, but with ice. High in cold mountain regions, Snow keeps falling, year after year. Over time, the snow becomes compressed into thick ice. This massive body of slowly moving ice is called a glacier. Although glaciers move very slowly, they are powerful enough to carve valleys, transport huge rocks, and completely reshape mountain landscapes. As glaciers melt, they leave behind piles of rocks and soil called moraines. In deserts, there is very little water, so another force takes over, the wind. Strong winds pick up tiny grains of sand and carry them across the desert. These grains slowly wear away rocks. At the same time, the wind deposits sand in different places. Over time, beautiful sand hills, called sand dunes, are formed. The wind is invisible, yet over thousands of years, it changes entire deserts. But not all of nature's sculptors can be seen on the surface. Some work quietly, deep beneath our feet, and their slow work creates one of the most beautiful wonders found inside the earth. Not all water flows on the surface. Some water slowly seeps underground through cracks in rocks. Over thousands of years, this underground water dissolves certain types of rocks, such as limestone. As a result, beautiful caves begin to form. Inside these caves, mineral-rich water slowly drips from the roof. Drop by drop, it creates hanging formations called stalactites. When the drops reach the floor, new formations begin to grow upward. These are called stalagmites. They grow extremely slowly, sometimes taking thousands of years to become large. So far, we've seen that most changes on Earth happen very slowly, but sometimes nature acts without warning. Heavy rainfall can trigger landslides. Huge masses of snow can rush downhill as avalanches. Glacial lakes may suddenly burst, causing dangerous floods called glacial lake outburst floods, or GLOFs. Strong winds in dry regions may create dust storms. These events remind us that although the Earth changes gradually most of the time, it can also change dramatically within just a few minutes. Understanding these natural processes helps scientists predict hazards and helps communities prepare for disasters.